this line of code right here calls the introduce self method, which we define as well. And the point is that this is this telemetry.update is important to getting your robot ready to run. So it's important that you have telemetry passed in as one of the arguments. These are called parameters. Now, we also define some functions. So testbot controls also has the functions introduce self, but then these right here are the main ones that actually have a controlling effect on the robot. And what they do is pretty self-explanatory based on the name of the function, which is very important when you're writing code. But also I'll explain, for example, let's talk through strafe left, for example. We have Mechanum wheels. So our robot is capable of strafing if we set up the power in a certain configuration. So for this right here, the reason that we set the front left and the back right to be negative, or negative power, by the way, means rotate. Say power means rotate clockwise. Negative will mean rotate counterclockwise. So these back right and front left motors are set to be rotating in a negative direction, while the front right and the back left motors are set to be rotating in a positive direction. And if you look up what happens to Mechanum bots when bots with Mechanum wheels when this configuration occurs, it ends up the bot moves to the left without needing to turn and then move forward, which is quite useful. More important though are, for example, straight drive. This one again makes a lot of sense. Given the left power and the right power, it just sets. So this dot left motors left power and this dot right motors right power. What this does is, given the arguments or the parameters that were passed to the function, it uses these two to change the actual speed of the left and right side. So we have a function called left motors, and what that does is it, given a certain power, for example, a power of 0.5, it will set the front left motor and the back left motor to that specific power. And those motors, those variables are variables stored inside the class, so we have access to them. And then if we wanted, so straight drive, if we wanted to realize how it works, we just look back to these two functions and we understand that it sets both left motors to be the left power and both right motors to be the right power. Now, if you have more questions about what all of these functions do, you feel free to leave a comment and we'll get back to you. But generally understanding how one strafe works and how one straight drive works should be enough. Turning right is just a matter of making the right wheels move forward. Sorry, making the left wheels move forward and the right wheels move backward, and that will turn the robot in a clockwise direction, otherwise known as turning it right. Now, this testbot.java file is where we use these controls, these functions that we've defined, to actually have the robot move. And this right here is where we create our testbot. So you'll notice that its type is testbot controls, and that's because we custom define that type over here. And you don't need to import it at the top because these two files are part of the same package, and packages share code, so you don't need to import it. Now, this wait for start and runtime.reset are functions that you need to include, or function calls that you need to include, because they make sure that your robot doesn't go out of control before you actually want it to, before you actually want it to move, it doesn't start moving. And then while op mode is active, so this is a function that you can import from, I believe that it's one of these imports, it might be this one or that one. It is a check to make sure that the robot is still supposed to be operating. Op mode means operational, mode. And what we do here is we define two variables. Now, these are variables because they depend on a gamepad. Now, op mode is active. This is a check to make sure that the robot is still supposed to be moving, so that the robot doesn't move after you have stopped its movement, either on the controller or on the phone. And this while just means repeat the code inside of the loop. So starting at here and ending all the way down here, repeat all of this code until op mode is no longer active. And the code, what it does is, first of all, it resets drive and turn. So drive and turn are variables that depend on gamepad 1. So that's the actual gamepad that we import from one of these packages up here. And that's the reason why drive and turn, they can't be constants. They actually depend on how far the left stick Y and the right stick X have moved. So at each loop, each time the robot goes through these instructions, and it'll do so very quickly, many, many times per second, it checks at that exact moment how much you're setting the left stick to go forward or backward, and how much you're setting the right stick to go left or right. So this is what we use to figure out how much the robot should be moving front, back, or how much it should be turning right, left. And this if statement right here, as well as this else if statement right here, compare the position of the sticks to the so-called stick threshold, which you remember we defined in the constants file. Now, the reason that this is important is because you don't want a tiny, tiny shift in the left stick Y. For example, you have your thumb on it and you accidentally push it up by a fraction of a millimeter. You don't want that to register as a movement. You only want the robot to start moving if you legitimately are trying to move it forward. And that would be, for example, if you have moved the left stick Y beyond the stick threshold, which is 0.3 for us. And the stick threshold goes between 0 and 1. That's a lot of, for example, power goes between 0 and 1. Sorry, excuse me. It goes between -1 and 1 because negative would be moving the stick down or rotating the wheels counterclockwise. But the idea is most values are going to be between -1 and 1, and they are percentages. So 1 is 100% or as fast as possible when it comes to power. Range.clip, just what this does is you take the drive value, you add it to turn, and then if that is way too small or way too big, because remember the values are between -1 and 1, then it clips, or so it basically limits how small or how big it can be to -1 or 1. And this is some clever math right here, drive plus turn and drive minus turn. And what this does is it takes the variables based on how much the stick on the left was pushed forward or backward, and how much the stick on the right was pushed left or right. And it uses those variables. If you add them together, you will get how much the left power should be moving. By the way, drive is actually, it has a negative sign right here, and that's that helps some of this math. You can think of it as if the left stick Y was pushed up. So the idea is we want our robot to be moving forward. Then drive will be set to negative, say, 0.7 because the left stick Y was pushed forward, which was positive direction. Then we would want the left power and the right power to be both the same, which is good because the turn will be 0, and that means that the minus and the plus will not affect the drive. But then something important here is that we want both drives to be negative, and that's because of the way that we set up our forward and reverse directions. If you had set these to be a different value than us, or even if you have a different robot, you will need to play around with whether this needs to be negative or positive. And I won't get into the full math because I can't sketch anything out on this video, but the idea is that you don't need to test out everything. All you need to do is try it without the minus, and that might calibrate it correctly for your robot. Feel free to leave a comment if you want to know more about that. Now, testbot.straightDrive is because we notice that the left stick Y and the right stick Y, the left stick Y is either below the threshold negative or above the threshold, and that means we actually want the robot to be moving. Now, we do change the left power and the right power so that if the right stick was moved, this turn will come into play, and straight drive will actually move it either left or right, in addition to moving it forward. So that's the if condition where the left stick was moved, even by up or down. Now, if it was not moved, but the right stick was moved past the threshold in either the left or the right direction, then that means that we want to strafe, because we're not telling the robot to move forward, right? This condition was not satisfied. The left stick Y was not up or down. It was just sort of in the middle. However, the right stick Y was being pushed to the left or right. That means we just want the robot to move left or right. And in this case, we would strafe to the right with this left stick X value. And what that means is, I apologize, not the right stick, the left stick. That's because the right stick is our turn, but the left stick is our strafe. So, in fact, we could introduce a variable here like this, double strafe, and we can set it equal to the left stick X, and that's how much we would strafe by if we indeed wanted to. My code isn't pasting, but the idea is that's how much we would want it to strafe by, and we would replace that with a variable right here. But hopefully you understand what I'm getting at, so we don't need to introduce another variable. So the left stick X is what controls how much it strafes to the left or right, and this code only runs if it has not been pushed up or down, if it's only been moving left or right. And finally, testbot.straightDrive 00 breaks the robot. Not breaks EAK, but breaks BRAKE, as in it stops the robot. And that's because, if you remember, we set 0 power behavior to be break, and so when we put both to be 0, it breaks. And this only runs if the left stick was not being moved up or down, and also not being moved left to right. And then finally, what we do here is we set the right trigger and the left trigger to, if they were moved beyond the stick threshold, to turn the robot, and that's another way to turn it. Both ways make sense. You could either move it you could move the left stick up or down and also at the same time turn the robot, or you might just want the robot to rotate in place without moving up or down, so called forward or backward, and that's when this would come into play. And that's it. At the end, you need to call telemetry.update, just like you called it at the very start inside of your testbot controls. So at the end of each moment, at the end of each loop, you need to call telemetry.update. And this right here is code that you don't need. This is something that we were testing out, but that we have not yet finalized. So we're not going to present it in this video, but feel free to stick around for a later video that covers this.